since we didn't have Math Mondays last week. This week we are doing something called Prejudiced Polygons. So we have some polygons. We have these triangles here that we can drag around, and they're going to be coming into this green neighborhood. We have these yellow triangles, and we have these bluish squares that will also be in this, that we're going to be putting in these neighborhoods. Okay, so these triangles and squares are going to be sharing the same neighborhood. Now, we will give out this Desmos link, so don't worry. I just want to explain the rules about what we're going to be doing today first, and then we'll get into sharing the Desmos link. So if you want to go about working on it for on your own, you can do that, or we can work on it together like as we usually do. It's going to be up to you. So here we have a couple examples of how the polygons are going to interact in this neighborhood. So the two things, two important things about polygons is that they are unhappy if fewer than 1/3 of their immediate neighbors are like themselves. Okay, so and they can also be unhappy if they have no neighbors. Okay, so in this first example that we see right here, the middle one is unhappy because if we take a look, there is only, it has the neighbors that it has is 1 square and 5 triangles. So we got 1, 2, 3, 4, 5 triangles, and it has 1 square neighbor. But the problem is that only one of those 6 neighbors is like himself or herself, like a square, right? So 1/3. So he's unhappy because 1/3 of their immediate neighbors is not like the square itself. Okay, so it's 1/6 is definitely less than 1/3. So we needed at least 2 squares around it so that it wouldn't be unhappy. So that we want to make them all happy. We want to make all the squares and all the triangles happy. So in that example, that's why this middle one is not happy. And if we take a look at this this second example, all the triangles and squares up here they're happy, they're okay. But this bottom one down here is unhappy because it has no neighbors. Okay, so make sure that whenever we're putting the triangles and the squares, we want to have those two things happening. We want them to be happy about the number of neighbors they have that are like them. And we also want to have them happy by actually having neighbors. Okay, so those two things, they want neighbors and they want to have at least no fewer than 1/3 of their neighbors to be like them. Okay, so Spencer, I think you can give out the link, so we can get started with this one together. So it looks something like this. So this is pretty much example 1, right? And we remember that for this middle square, the middle square is unhappy right now. And we're trying to figure out, can we move the triangles and the squares so that all of them, all the polygons will be happy? Okay, so Spencer put the Desmos link. If you want, you can go check it out for yourself and try moving things on your own. Uh-oh, Spencer got something. What happened? Uh-oh. Oh no. They have the link now. Is that the wrong one?
No, it's the right link. When I first posted it, I posted it just to panelists, so you were the only one who saw it. So everyone should see a link now in Desmos where you can use the same slides that Javier is using.
Yes. Okay. And if you so if we're working on these together, so take a few minutes just so that you know what the tiles represent. So just like before, I think we've done these with a few other activities that we've done here on Math Mondays. It goes from A1, A2, A3, and then B1, B2, B3, and then C1, C2, C3. Okay. I know it's kind of hard to see them when they are underneath these polygons, but that's our goal for this line. Okay, so if you want, you can take the Desmos link, try it on your own. If you are more comfortable doing these together, then stay with me and we can see if we can figure out how to make all these triangles and all these squares happy. Okay, so if someone has an idea, as usual, raise your hand and tell me how we can move the triangles and the squares so that all of them will be happy. And again, for right now, the square in the middle is not happy. So who can help me out and see if we can get all the all the polygons to be happy? All right, AJ, I did see your hand. I did see your hand. So let's call on AJ and see what happens. AJ, give us some ideas. Tell the rules. I can actually put them. Let's put them in the chat. Actually, let's put them in the chat. Give me 1 second, AJ. Let's put the rules in the chat so that we all can remember them. Let me put them in the chat. We have, these are the 2 rules we have. We got the polygons are unhappy if, I forgot to copy them. Give me 1 second. Do we got them? Oh, does someone already have them? Move the shapes around so everyone's happy. Yeah, we want to make everyone happy. And these are the 2 things that we have to do. Oh man, I can't copy them. But again, I'll explain them one more time. For some reason, I can't copy them. So they are unhappy if fewer than 1/3 of their neighbors are not like themselves, if whichever triangle or square that we're looking at. And they are also unhappy if they have no neighbors. Okay, perfect. Thank you, Spencer. All right, so AJ, give us an idea. Give us an idea of how to move these things around, these polygons around so that everybody is happy.
Can you guys hear me?
Yes, I can hear you.
Okay, move the blue down, move the blue in the middle down to C2.
Okay.
Move the triangle on C3 up to A2.
A2.
And that works, right?
Let's check. So let's go around. So here we go. We'll start with the square. It has 3 neighbors, 1/3, perfect, is like them, right? Okay, let's check this one. It has 2 neighbors. So if you happen to be late, don't worry. I'm explaining it right now. Yeah, Spencer put the link. So just like before, they are unhappy if fewer than 1/3 of their neighbors are like them, and they are unhappy if they have no neighbors. So this one's good. The one at C2 is good. The one at C1 is also good. It has 2 neighbors, and one of them is like them. Perfect. So that would be 1/2. This one, this triangle. So the neighbors also could include diagonals. So keep that in mind. Diagonals also can count as neighbors. So for this one, wait, let's see. We have 2 triangle neighbors, 2 square neighbors. That one is good, right? It's 1/2 and 1/2. What about this triangle in the corner? Also 2 neighbors, like itself. This one has 4 neighbors, like itself. Okay. This one has 2 neighbors, also like itself, and this also has 2 neighbors. So this one, it looks good.
Okay, next one. Wait,
yeah, let's go to the next one. Okay, thank you so much, AJ. Let's see if we can get somebody else to try the next one.
But shouldn't we start on number 1, not number 3?
What's up? The number one was just the rules and stuff, AJ.
Oh, okay.
Yeah. Okay. All right. Thank you, AJ. Let's go to the next one. Awesome. All right, let's see. So again, keep in mind, we're trying to use, for this one, same thing. we're trying to use all the squares that we have on the left side and all the triangles. We're trying to put all the triangles, all the squares, all these polygons into the neighborhood. And just like before, we want all of them to be happy. So again, keep in mind that neighbors include everyone surrounding them, including diagonals. So if I have this triangle here, the neighbors are all these around. So D2, D3, D4, C4, B4, B3, B2, and C2. So those would be the neighbors for this triangle on C3. So again, take a few minutes to think about how you would put the rest of these polygons into the neighborhood to make them all happy. So take a few minutes. Once you get an idea, raise your hand and we will call on someone. AJ, you have already gone, so we'll try to call on someone else first before we call on you, okay? I'll wait for a few more hands and then I'll start calling on someone. I'll wait for one more hand and see before I call someone to try this one out. One more hand, one more hand. If you have an idea. If not, you can always try out your idea on your own in the Desmos link and then share it with us. Okay, let's try Julia. Julia, I think, raised her hand last time. So let's call on Julia and see what her idea is. All right, Julia, you can unmute yourself. Hello? Uh-oh. Did this happen last time too, Spencer? All we hear is like a ringing sound.
Yeah, Julia. So in the bottom left corner next to your microphone, there should be an up arrow. You want to click on that and make sure that you're using the right microphone because right now we're just hearing static.
Can you hear us now?
Yeah. Do you mind turning that down just slightly?
You're talk quietly. I'm not sure how. Okay, Jason, come up and whisper. Okay, right up here, so we can hear you. Okay, can you hear us?
Yes, we can hear you loud and clear.
So, if you move the square, at the corner, that and up, so basically you just put the squares on one side and then the triangles on the other side.
So tell me what side you want to put the squares.
It doesn't matter.
Like all of them?
Yeah.
So let's say like this. You tell me if something is not the way you want it, okay?
Okay.
So far, I'm putting as many squares as I can to one side. Okay, I did as much as I could. Okay, maybe move this one to A3. What about this? What about the square that's on B1?
Move it to A2.
To A2, like that? Okay. And then what about the triangles? All fill them up?
Yeah.
Okay, I'll try that. Okay, ooh, almost there. There we go. Okay. And is everyone happy?
Mm,
What do we think?
no. There's a square at the top that's not. No,
Is it A2? Is A2 not happy or not happy?
it's not happy.
Why not?
Because there's only 2 squares and then. Wait, actually, it is happy.
Well, let's ask everybody. So type it in the chat. My question to everybody is A2 happy or not happy?
It is happy. Yeah, 2/5 is larger than 1/3.
Yeah. So Spencer and I are asking the question to everybody. Is A2, the square on A2, happy or not happy? And you can say yes or no. Ooh, a lot of yeses. Jason, you think is happy? Or I think it was Jason, right?
Go ahead,
You,
man.
you- yeah. You think it's happy? You think it's happy? And why?
Because 2/5 is larger than 1/3.
Ah, very nice. I think someone also said it in the chat too. Perfect. Perfect. And everybody else is happy too? Not just A2?
Yeah.
Everybody else? Perfect. Okay. Something like this one has 3 triangles and 2. Perfect. Yeah, I think everybody else is happy. 1, 2, 3, 4, 5. Yeah. Even this triangle in the very corner, A1, I think also happy. Perfect. Thank you so much. Thank you so much, Jason. All right. Should we go to the next one, Spencer?
Yeah. So everyone who's following along on Desmos, you should actually have access to a new slide now. So you should be able to go over to slide 5.
Okay. Yeah. So for now, I think what is Spencer is saying that we restricted you up until this slide, but now that we've gone through this one, you should be able to go to this slide now. So let me zoom in my screen just so that we can all see this one. Let me go a little closer. All right, there we go. So now, same thing. What we want to do is use all polygons. So we have 12 squares and 7 triangles on this 5 by 5 neighborhood. And we want to see if we can make everyone happy again here in this neighborhood, the 5 by 5 neighborhood. Okay, so again, take a few minutes, a minute or so. Try it out for yourself and see if you can come up with how to make all the polygons happy. Again, once you have an idea, raise your hand and I will call on one of you to share your idea. AJ, let's wait for a few more. Yep. Yeah, let's see if we can get some more. I'll wait for another 30 seconds and see what happens, okay? If we get more hands. A few more seconds. Oh, here we go. Now we're getting more hands. Oh, look at that. Okay. Yep. Anu Rajani has been waiting very, very patiently. So let's call on Anu Rajani. Okay.
Hi, can you hear me?
Yes, we can hear you.
Okay, so I had all the blue squares go at the top. So A1, A2, A3, A4, A5, B1, B2, B3, B4, B5, C1, C2.
Okay, I'm working. I'm I'm trying to catch up. All the way to C2, right? You said?
Yeah.
Okay, almost there. Perfect. And then what about the triangles?
And then the triangles fill the bottom row and then go to D4 and D5.
D4 and D5. Ooh, okay. All right. And is everyone happy? Is
Yep.
everyone happy? Yep. Ooh, very nice. Yep, it looks like everyone is happy. Thank you so much, Anurajani.
Thank you.
So, yeah, of course. So if you found a different way, should we call on a different way, Spencer, or should we go for the next one?
Well,
Or we should,
looking at this one, it looks like nobody's really kind of mixed together, right? Like we have all of our squares on one side and we have all of our triangles on entirely different side. They're not even neighbors at all. There's not a single square neighbored with a triangle or vice versa.
yeah, we kind of have this separation going on with D1, D2, D3, C3, C4, and C5. Yeah.
Yeah,
Mhm.
so it's pretty easy to meet the conditions then if we just keep them entirely separate. But what if we wanted to have them actually mixed together so that we had as many different squares and triangles as neighbors as possible?
Mm. So so what Spencer is saying, we want squares to be neighbors with triangles and triangles to be neighbors with squares. They don't all have to be, but we want them to be a little bit more mixed, right? Right now we have a bunch of triangles on one side, a bunch of squares on the other side. Well, is there a way to make them, is there a way to make everyone happy so that at least a good amount of them are neighbors with each other? Can we do that? Let's go to the next slide. That's what we want to do with the next slide. So can you think of a way to make everyone happy where their neighbors, where a good amount of them are neighbors with each other, at least? They don't all have to be neighbors with each other, but at least some of them. See if you can come up with something where that's the case, where they're a little bit more mixed and not separated like we had with Anurajani's idea. But again, Anurajani's idea was great. Everybody was happy. But now we want to see if we can make them really neighbors. oh, JL had an idea. And then disappeared. So again, raise your hand if you do have an idea. I know AJ, you did have an idea. I see you, but let's let other people try. Yeah, let's give everybody a minute or so to try and see if they can figure out how to go about this. It's a little different now that we want them to be a little bit more mixed. Okay, more next to each other even. So again, take a minute. If you have an idea, share it with us. I'm sure a lot of us would want to see your ideas. All right. All right, Anurajani, did you have another idea? Let's call on Anurajani one more time. Did you have
Yeah,
an idea to make? Okay,
I
go ahead.
think that it works. So I had the same arrangement of blue squares as I did last time. So all the way up to C2.
Okay, so since we already put that all the way over here, we'll use this one. Okay, so we'll just use your idea here, okay? So now tell me, what else would you move?
Then I put the 3 triangles C3, C4, C5.
Okay,
And then I put the triangles in D2, D3, D4, and D5.
D2, D3, D4, and D5. Ooh, okay. And is everyone happy here too?
I'm pretty sure.
Okay, so it looks like everybody is still happy. I think so. Yeah, I think everybody's still happy, right? This one, it looks like 3 neighbors are blue squares. This one has 2 neighbors and 2 neighbors. Looks good. This one has 4 neighbors and 4 neighbors. I think this does work. But yes, Julia, just like what Julia or Jason is pointing out, we want it to be a little bit more mixed. And but thank you so much, Anurajani. We love the ideas. Okay, it's getting closer to what we want. Now at least they're not separated, right? At least they're closer, and they're really neighbors. But we want to mix them up a little bit more. Mrs. M had her hand raised, but if not, that's fine. We can ask Abigail. Abigail? Oh, maybe Miss M does have an idea. Let's call on Mrs. M. Okay, Ms. M, did we have an idea? One of your students have an idea?
After Abigail.
What's that?
We can go after Abigail.
Okay, sure. Okay, Abigail, we'll call on you up and see
Before Abigail goes, do you mind answering just a bit? What do we mean by mixed together? Can you just say again for everyone?
Yes, so mixed together, we not only do we want them, I'll show a little example. So when we want mixed together, we don't want one group, we don't want all the group of squares to be on one side and then all the triangles to be on the other side. So they don't all have to be mixed. They don't all have to be neighbors with all of them, but something like this would be more mixed where they're kind of like more separate. All the blue squares are a little bit more separate. All the triangles are a little bit more separate from each other. They're not all on one side, whereas the triangles are on the other side. So something like this, it doesn't have to be exactly like this, but we can see here, just from the ones that I've put, we can see that the squares and the triangles live kind of mixed together. And I know that's still kind of hard to think about, but we definitely want them to share the same space, kind of.
Yeah, if you go back to slide 5, you could kind of see that there's like a neighborhood of squares on top and a neighborhood of triangles on the bottom, and they're just kind of like separated from each other. So
Yes.
we want to see if they could exist in the same space and not kind of like have this almost like a wall between them.
Yeah. So even here we can still draw a line where there's a separation, right? If we draw a line going through these edges, we can still see that there's some blue over here and there's some and the triangles are all on the other side of that edge. Whereas in this example that I made here, there isn't really an edge I can draw that would separate the two. So that's what we mean by mixing them. Okay. Okay. So let's see. We can ask Abigail and see if they get an idea. Abigail,
Yes. So,
do you have an idea?
yes.
Okay, let me know.
Can you hear me?
Yeah, I can hear you.
Hear me?
Yes, of course.
Mhm.
Let me know.
So,
Where do
in
you
one,
put the triangle?
A1, A2, and A3 for the blue.
Those are the triangles. Oh, for the blue. Got it. A1, A2, A3. Okay.
And then 2 triangles for A4 and A5.
Oh, okay.
And then the blue boxes for B1, B2, B3, B4.
All the way to B4.
And then a triangle
Okay.
for B5.
The triangle on B5.
Yes. And then the blue boxes for C1 and C2.
C1 and C2.
And then triangles for C3 and C4.
C3 and C4.
And then a blue box for C5,
The blue box for the C5.
D2, and D5.
Is squares or triangles?
Squares.
Okay, D2 and D5.
And then the triangles for the ones in between.
For the D3, D4?
Yeah.
All right. So we definitely have the neighbors. So Harvey said we want the blues really want to be neighbors with the yellows, and the yellows really want to be neighbors with the blues. Perfect. That's exactly it. We're getting better at, Abigail, your idea is getting better at making them neighbors with each other. This is good. This is great. And is everyone happy? So let's ask the chat, everybody here, does everyone agree that is everyone happy in the neighborhood that Abigail made? Is everyone happy here? AJ saying happy. Lorraine saying yes. Anu saying yes. Ooh, I think everybody's agreeing. 1/3. Yeah. This is 3, 4. Yeah. Wow, very nice. Abigail, awesome. Thank you so much, Abigail. Ooh, that's a very good question. So what Spencer's telling us, is there a way that we can make as many squares neighbors with triangles and triangles with squares? We're trying to get as many of them to be neighbors with each other. So right now we have some that are neighbors with each other, but we still have these 4 squares down here that are not neighbors with any triangles, right? But otherwise, I think we have the rest that are neighbors with triangles and squares. But so right now, we don't have these 4 that are neighbors with any triangles. So what do you think, Spencer? Should we call it? It is 2:30. It's past 2:30.
So we can show the next slide, which
Oh,
has
yes.
a few more resources if they wanted to keep going with this activity.
Yes, of course. So I'll show you the links. So for this first one, there is a website that V Hart and Nikki Case made about these polygons. So what you can do is take a look at the website and try out. They have a bunch more maps. They have a bunch more maps, way more than we've done. And you can always click a new board and they're way bigger too, as you can see. And you can always make a new board and try to make everyone happy. You see that there's a bunch of smiley faces. There's also some kind of concerned faces. So take a look, try them out. You can go to that website at the very end. It's on that last page of the Desmos. And you can also take a look at these slides a little bit more about what we were doing here. So we've been wanting to make the triangles and the squares a little bit more, we wanted them to be more neighbors with each other because it's something that could be related to a bunch of things in real life. So you can click on this link to learn more about how it affects more our daily lives. Yeah. And see a little bit more about where this activity came from. Otherwise, I think we are done for today. So again, check out the Desmos link. If you haven't already gotten the Desmos link, you can check it out. Spencer, could you post it one more time for everybody in the chat? If they haven't gotten it, they can check out the link. Yep, there we go. So that's the link right there. So if you want this link, just go to the very last page and you'll find both of those links to the slides and to the page with the big boards, okay? So yeah, there you go. Spencer also put that one in the chat. So otherwise, you should have all the links. There we go. We got the first link is the Desmos app. The second link is this page that I opened here. It should be. And then the third link is the slides. Mrs. M, you should be able to see it. Oh, there we go. Oh, he's putting him, he's posting him so that I can see it. There we go. Here we go. One more for everybody. There you go. There is all three. The first one again, the Desmos link. The second is the one that I'm showing right now, that I'm sharing with everyone. And the third link is the slides that I was talking about. Otherwise, we are done for today. Happy Monday, everyone. And we'll see all of you hopefully on next Monday for the next activity that we have. Okay, otherwise, bye everyone. Bye, have a great Monday. Bye.